Hello and welcome to lesson 3D congruent triangles. Today we're going to focus on whether or not a pair of triangles is congruent and identify why they're congruent. So we learned in our triangle zoo activity that we have several methods to prove a triangle congruent. Let's review what those are real quick. We have the SSS, side 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 method, SAS, side angle side, ASA, angle side angle, AAS, angle angle side, and HL, hypotenuse leg. Those are the 5 ways that we can prove a triangle congruent. So let's take a look at these triangles and figure out if they're congruent, and if they are, why they're congruent. So when I look at two triangles to determine if they are congruent, I look at their markings, and I make sure that the markings are in the same order, which these are, and then I identify what is marked. Here we have an angle and a side marked, and if I looked, I've got 2 angles and a side where the side is not included between these 2 angles. So this means that triangle SRT is congruent to triangle VWU, and again, I'm using corresponding pieces here, making sure they go in the same order, by AAS, because it's 2 angles and a side where the side is not included. So from my list, that's this one right here, where 2 angles and a side where the side is not included between the 2 angles. Let's look at our next one. Here I've got 2 triangles, and when I look at what's marked, we've got 3 sides marked. That's probably the easiest one to figure out. This means that triangle ABC is congruent to triangle QPO by side, side, side. And moving right along, here I've got a side, and an angle marked. And guys, this is not one of my congruence laws. SSA, or if we spell it backwards, ASS, it's a bad word, therefore it's not a congruence law. That doesn't work. However, because this is a right angle, I can relabel these. Across from the right angle is always your hypotenuse, and then any other marked sides are legs. So what I have here is actually HL. So these are congruent. So I can say that triangle XYZ is congruent to triangle BCA by hypotenuse leg, by HL. All right, let's look at this next one. Here, I've got 2 congruent right angles and 2 congruent sides, but that's only 2 pieces of information, and I always need 3. So I've got a pair of parallel sides here, so I can actually mark these 2 angles congruent by the corresponding angles theorem. So what I end up having here is an angle, a side, and an angle marked, where the side is included between both the angles. So these are congruent. So I can say that triangle JKL is congruent to triangle LMN by angle, side, angle, ASA. And let's look at this diagram here. Here again, I only have 2 pieces of marked information, so I'm going to add the center angle here because that's a vertical angle, and vertical angles are congruent. So what I have marked here is a side, an angle, and an angle. And looking at this, the side is not included between the 2 angles. So I can say that triangle ABC is congruent to triangle EDC by AAS, because my marked side is not included between the 2 angles. Now looking at this diagram here, I've got a marked side, and if this is 90 degrees, this is also 90 degrees. And we also have a shared reflexive side. They're overlapping triangles, so I know that they both share that GI. And so what I have marked here is a side, an angle, and a side. So these triangles are congruent. So I can say that triangle FIG is congruent to triangle HIG by side, angle, side, because the angle is included between the 2 sides. All right, guys, it's the end of this very short lesson. Please take a look at the MML, and good luck. Thank you.